If you're building machine learning on Azure, you'll quickly hit a fork in the road. Do you standardize on Azure Machine Learning, often shortened to Azure ML, or do you run your ML workloads on Azure Databricks? Both can train models, orchestrate pipelines, and serve predictions, but they optimize for different teams and different problems. In the next few minutes, I'll walk through Azure ML's three core building blocks: the workspace, pipelines, and endpoints. Then I'll put it side by side with Databricks so you know exactly when to reach for which. Let's get concrete. Everything in Azure ML lives inside a workspace. Think of it as the top-level container and control plane for your ML assets. When you create one, Azure provisions a bundle of dependent resources: a storage account for data and artifacts, a key vault for secrets, a container registry for your model images, and application insights for telemetry. Inside the workspace, you register datasets, compute targets, environments, models, and experiments, all tracked with versioning and lineage. Access is governed through Azure role-based access control, so a data scientist and an ops engineer can share the same workspace with different permissions. The key idea: the workspace gives you one governed place where experiments, models, and deployments are all linked together. A pipeline is how you turn a messy notebook into a repeatable production-grade workflow. In Azure ML, a pipeline is a directed graph of steps: pull and validate data, featurize, train, evaluate, and register the model. Each step runs in its own environment on its own compute target, and outputs are cached, so if only the training step changed, the earlier steps don't rerun. You define pipelines with the Python software development kit, the command line interface, or YAML, and you can trigger them on a schedule or from an event. This is the backbone of MLOps in Azure ML: reproducible runs, tracked metrics, and a clear path from data to a registered model you can deploy. Once a model is registered, endpoints are how you serve it. Azure ML gives you two flavors. Online endpoints are for real-time, low-latency inference over HTTPS. They support multiple deployments behind one endpoint, so you can do blue-green or canary rollouts by splitting traffic, say 90% to the old model and 10% to the new one. Batch endpoints are for scoring large volumes asynchronously, where you submit a job and collect results from storage. Both manage the underlying compute, scaling, and authentication for you, so you're not hand-rolling a Flask container on a virtual machine. That managed serving layer is one of Azure ML's biggest differentiators. Now, the close alternative. Azure Databricks is a Spark-based lakehouse platform. Its center of gravity is large-scale data processing and collaborative notebooks, and it brings ML capabilities through managed MLflow for experiment tracking and a model registry, plus model serving endpoints. If your features are computed over terabytes of data, or your data engineering and ML teams already live in the same Databricks workspace, doing training right next to the data is a real advantage. Databricks also leans toward code-first and Spark-native workflows. The trade-off is that you're managing clusters and Spark, and its serving and governance story is improving, but historically less turnkey than Azure ML's managed endpoints. So where does each one hurt and shine? Azure ML shines on MLOps governance and managed serving, registered models, traffic split endpoints, responsible AI tooling, and tight Azure role-based access control. It hurts if your core need is heavy distributed data processing, because it isn't a Spark engine. Databricks shines on big data feature engineering and unified analytics with ML on the same platform. It hurts on cost discipline if clusters are left running, and its deployment and approval workflows can feel less prescriptive than Azure ML pipelines. Worth noting, these aren't mutually exclusive. A common pattern is engineering features in Databricks, then training and serving through Azure ML, since both speak MLflow. On cost and operations, both bill you for the compute you run, but the levers differ. In Azure ML, you pay for compute clusters and instances, plus the always-on infrastructure behind online endpoints. So right-size instances and let clusters scale to zero when idle. In Databricks, you pay Databricks units on top of the underlying virtual machines, and idle interactive clusters are a classic source of bill shock, so configure auto-termination. Both support spot or low-priority virtual machines to cut training costs dramatically when interruptions are acceptable. Pricing and feature parity shift constantly here, so always confirm current rates and capabilities in the Azure docs before you commit an architecture. To recap, Azure ML gives you a governed workspace, repeatable pipelines, and managed online and batch endpoints, making it the stronger choice when MLOps lifecycle, traffic split deployments, and access governance are your priorities. Databricks wins when your work is dominated by large-scale data processing and your teams already live in the lakehouse. Here's my rule of thumb. If serving and model governance are the hard part, start with Azure ML. If wrangling terabytes into features is the hard part, start with Databricks and connect the two through MLflow if you need both. One concrete next step: spin up an Azure ML workspace and deploy a registered model to an online endpoint with a 90-10 traffic split. You'll feel the managed serving advantage in about an hour. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.